Hello everyone. Today we're going to look at the last part of this chapter, the geometric proofs on circles. Let's first go through all the theorems we have learned in these two chapters. Chapter 10. It's the best. I think it's the best that you can do to look at the summary, the chapter summary in the textbook. On page 57, you can see the first group, 1A, B, and C. Now these three are what I call the symmetrical properties of circle, about chords. And you must be very familiar with the perpendicular from center to chords bisects chord, line joining center to midpoint of chord perpendicular to chord, and perpendicular bisector of chord passes through the center. The next group are 1D and 1E. They are the relation between the chords and the distance from the center. They are equal chords equidistant from the center, and chords equidistant from the center are equal. The next group is about angles. We have the relation between angle at the center and angle at the circumference. So 2A, angle at the center twice angle at the circumference. 2B, angle in the semicircle. 2C is the converse of angle in the semicircle. 2D is that angle in the same segments are equal. Now usually you will just see a figure with angle A and angle B. Now you can see that there are many positions for CDE. You can actually change the point to any point on arc AB, and the angle will keep the same. The next group is a relation between angle, arc, and chords. The equal relations, we study the equal relations as a group. There are 6 of them. Equal angles, equal arcs, equal arcs, equal angles, equal angles, equal chords, equal chords, equal angles, equal chords, equal arcs, equal arcs, equal chords. You can use it basically any order you want. You put the condition first and the conclusion second. The last group of theorems we learn on circles, they are the proportional relation. That is, arcs proportional to angle at the center and arcs proportional to angles at the circumference. Moving on. In chapter 11, we started with the properties of cyclic quadrilaterals. This is the first group, 1A and 1B. Opposite angle cyclic quad. Exterior angle cyclic quad. And then we learned 3 tests for cyclic quadrilaterals. 2A is the converse of 1A. Opposite angle supplementary. 2B is the converse of 1B. Exterior angle equal to interior opposite angle. 2C is the converse of angles in the same segment. The next group. In the next group, we talk about the tangents to circles. 3A, tangent perpendicular to radius. 3B, the converse of tangent perpendicular to radius. 3C is what I call a symmetrical property. So if you have 2 tangents from one external point T, then you have 3 conclusions. One is that the 2 tangents are equal. The second one is angle at the center are equal. The third one is the angle at the point T are equal. Symmetrical properties. Next group. Now these 2 are often overlooked because they don't have a reference, but you should remember the results are very, very important. For 2 circles are said to be externally tangent to each other, the distance between center and center is equal to the radius plus radius. If they are tangent internally, the distance between center and center is equal to the difference of the radii. Last. These 2 is the angle formed by the chord and tangent chord angle is equal to the angle inside the circle in the alternate segment. And the converse is also true. If the angle formed by the tangent and the chord is equal to the angle in the alternate segment, then this line passing through one end of the chord is a tangent. That's all.